This is an audio description for GCSE Geology, Theme 3, Question 3. Part B. Crystallization from a melt. Rock 1 is an igneous rock. It consists of random interlocking crystals. Those crystals are all roughly the same size, and they're about 5 millimeters across. Rock 2 is also an igneous rock, which again consists of random interlocking crystals. The crystals in this rock are only just visible. Each crystal is about 0.5 millimeter in size. All the crystals are the same size. Rock 3 is also an igneous rock. Again, it consists of random interlocking crystals. The crystals in this rock, though, are different sizes. There are some large crystals up to 1 or maybe even 2 centimeters across. Each of those crystals has a distinctive shape with straight edges. Those crystals are surrounded by a mass of smaller crystals. The smaller crystals are all about the same size, and they're about 1 millimeter across. Rock 4 is also an igneous rock. In this rock, there are no crystals visible at all. The rock has a dark, quite shiny surface. It resembles a lump of black glass, and the crystals can't be seen even with magnification. This is the end of the audio description for Part B. This is an audio description for Theme 3, Question 3, Part D, Metamorphic crystallization. The first rock is gneiss, spelt Gneiss. This rock is completely crystallized. The crystals are 2 to 3 millimeters across, and there are several different minerals within the rock. There are minerals of feldspar, which are white or pink in colour, grey minerals of quartz, and dark crystals of biotite mica. The rock has completely recrystallized. There's no trace whatsoever of the original rock material. There are distinctive bands of different coloured minerals that run through this rock, alternating between light and dark colours. The rock itself almost looks igneous. The second rock is marble. Marble is partly crystalline. there are some faint traces of the original limestone rock that was metamorphosed. The crystals in this rock look like they've been fused together. There's no overall alignment of any of the minerals in this rock. The final rock is schist, spelled Schist. Schist has very small crystals, maybe 1 millimeter across. It's generally quite dark in colour. We see an alignment of mica minerals running through the rock, all running parallel to each other. The rock is largely recrystallized, and very little trace remains of the original parent rock. This is the end of the audio description for Part D. This is the audio description for Theme 3, Question 3, Part G, Sedimentary Rocks. Rock A has a mixture of clast sizes. Most of the clasts, or fragments of rock, are rounded pebbles. Those pebbles range in size from about 8 millimeters up to about 30 millimeters across. Those pebbles are surrounded by finer grain clasts of sand, and the pebbles are cemented together. Rock B has large clasts of rock. These clasts are a variety of sizes, the largest being 50 or 60 millimeters across. All the clasts are very angular. They have sharp corners, and there's a complete mixture of sizes of them with no overall order. The clasts are surrounded by a white mineral. Rock C has clasts that are much smaller. These clasts are about a millimeter across. All the clasts in the rock are the same size. All of those clasts are very well rounded, so that those clasts are almost spherical. A red mineral, hematite, is cementing these clasts together. This is the end of the audio description for Theme 3, Question 3.